Hi, my name is Vian from Rensburg. Recently I got the opportunity to go for an internship in Japan. While I was there, I got the opportunity to work on a few great projects. While I was there, I worked along with professors and students at the university to design a sound meter. Now, what this sound meter encompasses is a lot of components, some of which I've already done in a lot of physics modules, along with some advanced knowledge of the university, what they provided me with. So, how we came up with this sound meter was the main problem of sound pollution. And how do you control it? How do you measure it? And sound pollution is a very tricky problem because people get used to it. It's not very easy to measure it. So, especially in recent times, sound pollution has become quite a problem with airports, construction sites, metros, especially in very densely populated cities. London, Tokyo, New York. Those are very difficult to keep that sound to a minimum. A lot of engineering these days takes place on how to reduce that sound. Aircraft engines with one of them, metro designs, those are a few examples of how people have tried to minimize sound leakage. Now, some of the problems that come up with sound pollution is insomnia, hearing loss, and eventually the deterioration of mental health. This problem is also very apparent in sea routes. People don't often think about the consequences of sound underwater, especially underwater because it travels a lot faster, especially aquatic life. Whales, dolphins, fish, they're very sensitive. They have very sensitive sensory organs which can be very easily disrupted by the very heavy and low frequency vibrations of ships. This can cause damage to their highly sensitive hearing organs, and it can eventually lead to the life form being stranded. This creates especially very sound sensitive aquatic life. You can think of whales, dolphins, fish. They're very sensitive to any underwater pressure that sound might interfere with them with. In these cases, a lot of that needs to be measured appropriately and measures have to be taken. Now, how do you measure sound? Of course, we need to measure sound first before we can address the problem. And sometimes it works better being able to measure sound will make it a lot easier to take the necessary steps to keep that sound isolated. Now, sometimes we don't know how much insulation is too much. You need to look at your costs. You need to keep costs to a minimum, and therefore you need a sound meter to understand what the level it is at. So, in order to detect the sound, you need an input signal. This input signal via a microphone can be either a lapel mic, a condenser mic, or a dynamic microphone. In my case, I wanted to take the simpler, easy route and simply use a condenser mic. Now, how this condenser mic works is the sound hits a diaphragm. This oscillates the diaphragm and creates varying voltages that can be picked up. Now, this small voltages can't be very easily measured with an oscilloscope or your volume unit indicators or your liquid crystal displays. You need something to amplify that signal. And to amplify that signal, you will need an operational amplifier. Now, what the operational amplifier does is it takes that very, very small DC signal and it amplifies it. And as it amplifies it, it can actually be read by your liquid crystal displays or your volume unit indicators and can actually produce enough voltage. Now, as you might imagine, the condenser microphone will produce alternating voltage. That's how we speak. Sound waves travels in waves. And these waves cannot really be read by your standard measuring equipment. By example, for my case, the volume unit indicator can't measure alternating voltages. So you'll need a component in order to rectify that signal. And what I mean by rectification is it can only read the positive signal input. Now, in order to do that, you can use a simple diode or a full bridge rectifier if you really want to step things up. But what the diode will do is it will cut out the negative part of the signal, and it will only produce the positive inputs from the microphone. Now, to measure these decibel levels, you need certain steps in order to detect the sound, process it, and find a suitable way to present that data. Now, the first step is obviously a microphone. There are many different types of microphone. There's the simple lapel mic that I'm wearing now, and there is also other types of microphones. For example, the one that I've used in my project is the condenser microphone. It's a very simple microphone, very cheap. It works essentially the same as a capacitor with a small vibrating diaphragm that as sound waves hit the diaphragm, it oscillates. This oscillation causes a potential difference across the ends, although it's very small. Now, how do we detect that small potential difference, and how do we display that? Now, this very small input signal from the microphone, this is amplified by use of an operational amplifier. It's a very small chip, usually about 8 legs, and this takes that input signal and amplifies it to a region where you can actually measure it. Usually these small mics, they don't produce enough potential difference to actually measure it with your standard measuring equipment. Therefore, you need an amplifier to boost that signal, so in order for it to be readable and understandable at that. Now, the operational amplifier can take many forms. It can be used for many different applications. But in this case, very simple, it only amplifies the signal. That amplified signal, after it has been amplified by the operational amplifier, it has to go through a few more steps before it can actually be displayed. Now, the oscillations produced by the microphone, that is amplified by the amplifier. So the analog AC signal from the microphone, amplified by the amplifier, will not be able to be displayed on an analog meter. You won't be, for example, use a volume unit meter. That will not work. For that, you'll need a DC signal in order to power that simple analog meter. You can, for example, measure it without the rectifier using an oscilloscope. However, that's not very practical and definitely not space efficient. In order for the AC signal to be converted into a DC signal, what you will need is a basic rectifier. Now, this can go from a simple diode to a full bridge rectifier. Now, what this rectifier does is it flips the negative part of the signal over in the case of a full bridge rectifier. But that can sometimes be a bit cumbersome, and it's not really very efficient in a small circuit. So in this case, we use just a simple diode to cut out the negative part of the signal and simply feed the positive part through. This part will be later on converted into a DC signal via smoothing. Now, smoothing takes place after the wave has been rectified. Now, what smoothing basically does is it takes that peaks and it produces a relatively stable DC signal. Now, how this works is simply connecting a capacitor in parallel with the output signal. Now, what this will do is it will take the peak value of the rectified signal and keep it there for as long as necessary. This will produce a relatively constant DC output that you can measure with your standard volume unit indicator. Otherwise, it will produce an oscillating function that will not be able to be read very easily on the volume unit indicator. Now, for the output displays, there's a multitude of options that you can choose from. You can choose from a simple liquid crystal display, a volume unit meter, or just simple LEDs in series. However, for my project, I decided to go the simplest route and simply use a volume unit indicator, which is basically what it says. It simply produces a unit of the volume that it picks up. The more intense the signal, the higher the reading of the volume unit indicator. Now, obviously, when you're using liquid crystal displays or other forms, you might need to program that display first before you can use it. Now, once you have the volume unit indicator set up, there's a few steps that you still need to take. How do we know, how is it possible to determine the decibel level from the input signal that we got? Now, in order to do this, we need to calibrate it first. So what I did in order to calibrate it was I took a microphone that emitted a constant frequency at a specific decibel level, and I put that very close to the microphone. Now, the output signal that you got from that will be detected by the volume unit meter. You note those two values, and you change, as you go on, you change the decibel level from your emitter, whether that be a speaker, from your phone, laptop, whatever. Then you change that level and you read according to the volume unit indicator the changes. Now, once you have a set of data, you can, if it is a straight line function, which it should be, you can set up an equation. And from that on, you can determine the reading on the volume unit indicator from whichever decibel level you put in. Now, some improvements that you could make to this circuit is you could add, for example, an Arduino microcontroller. This could make the analysis and detection of data a lot easier. You can program it with a liquid crystal display, and that could make readings a lot easier than from reading it from an analog display signal. This data that you record can also be stored on a computer and can be used for later use. Now, some of the challenges I faced would definitely be the wiring. It was very small circuit, lots of small wires. It was quite difficult at times to properly solder the right components into the right places where they should be. It was definitely not an easy task. More than once had soldered accidentally the wrong component in the wrong place. But that was quickly and easily rectified by the help of my professor. Definitely one of the challenges was also the language barrier. However, I think we quickly overcame that struggle very early on. And yeah, I think it was a very valued experience. Other than the actual project at the university, we had a lot of fun walking around Tokyo, exploring the sites, investing ourselves in the culture, trying new foods, doing new things. It was genuinely a valued experience that I will always remember through my life.